In this video, we're going to discuss the Traceroute utility. Earlier, you saw a demonstration of ping. Ping is used to be able to tell if another device is active on the network and if it's reachable from your device. Now, there are other utilities that we use frequently in networking. One of the main ones is Traceroute. Ping tells us if a single computer is available. But what if a ping fails? How do we know where the problem is? In a small network, a peer-to-peer network, it's pretty easy. If it's not me, it must be you. But in the larger enterprise-type networks or the internet, sometimes it's very difficult to figure out where the problem might be. So, the Traceroute utility works like this. Let's say this is me at my computer here, and I'm trying to bring up the web page www.cisco.com. And say it doesn't come up. So I try to ping www.cisco.com, and I get no response. So now I need to be able to figure out where along the way did my packet get lost. So, the message originally comes from my computer to my default gateway. Now, default gateways are always routing devices. So, at each hop along the way, a routing device is going to make a decision on what's the best way to get where they're going. So, my first hop router, or my default gateway, is going to decide which way is the best way for me to get to Cisco.com. And there may be many networks connected to my router, but there's only one that follows the correct path. So my packet is going to go to my default gateway router, and then it's going to be forwarded to the next hop that is the best path along the route to Cisco.com. So let's say this is router number 1. So my first hop is 1. My second hop is 2. Now the same thing's going to happen at router number 2. It's going to decide out of all of its available paths which path is the best way to get towards Cisco.com. So it's going to forward my packet to router number 3. So now I have all of these hops in sequence. Eventually, this is going to travel through many routers to the point where it enters the Cisco.com domain. And at this point, I'm going to possibly be able to reach the Cisco.com web server. But at any point in time, if the router does not have a path to get to Cisco.com, or say, for example, that path no longer functions, my Traceroute to get there is going to stop. Traceroute utilities report back each router that the packet successfully makes it to. So if I get to this point and I have correct responses from routers 1, 2, 3, and 4, I know if I can't get any further that I need to find whoever owns router number 4 and try to figure out why my packet won't make it the rest of the way. Sometimes these problems are physical problems, sometimes they're logical problems. But Traceroute helps us find where the problem does exist. Where does our packet stop in the path along the way? A successful Traceroute will get all the way to the destination, and the final entry on the Traceroute will be the destination server. So my Traceroute would then include also routers 5 and 6 before the last hop of www.cisco.com. Now we're going to go to the PC and see a demonstration of how this works.